Yes, sir.
Um, so I'm going to give a little bit of introduction to Git, just in case people are new to it, because I didn't know what the audience would be. Um, just, what is Git? Um, the motivation behind it, it started with Linux. It started with Linus Torvalds. He's the main author of it and originator. And the reason he started it was because they had adopted a commercial system called BitKeeper that changed their policy over time and made it less friendly for their use. So they ended up having to drop use of that and replace it. And I guess not to their benefit, because Git's way more popular than BitKeeper ever was. It's very fast. It's made for distributed. One of the problems they were trying to solve with it was that to support distributed development. So it's very well suited to that. Also nonlinear development, so being able to move commits from one place to another very easily, sort of merge different streams of development with each other. It's very powerful that way. To prevent corruption, I've never lost anything, but I committed to Git. Neither through corruption or even my own carelessness. I don't think I've ever lost anything. There's always a way to get it back. So they've done an amazing job at doing that. This snapshot versus delta, I just put that in there to remind myself that the Git model is not a file-based model. So if you come from a CVS type system, for instance, where they're tracking files and each of the files has a history, that's not true in Git. The unit of commit, if you want, or is the entire state of the system. So the entire project. So files, of course, will be tagged in Git, and their changes are modeled, but really what you're getting in each commit is a snapshot of a project at that time. It's not an individual history of each file. Just gonna So just some mental concepts to keep in mind, because it's quite powerful. I'm going to be using the command line, by the way, through this to illustrate. And there's a website that I'll be showing you where you can go and practice without worrying about doing commits. It's a very well built site that allows you to practice Git commands. It's not quite exactly what you would type, but very similar. So each of the commits that you make, you can think of as a node in a tree, and that's actually what is being stored in the Git repository as a tree. If you picture that as a bunch of nodes, I'll just flip over to a picture here. So if you think of it as a bunch of nodes in a tree, and then we have various ways of referring to those nodes. These are the main ways of referring to it. So the SHA is kind of an internal reference. It's usually a long, you'll see a number that looks like something like this. It's actually longer than that. Those are truncated. Another way of referring to possibly the same node is head. That has some special meanings we'll talk about. There's also ones that you can construct yourself, which are branch. These are user-controlled labels, but they have some special behaviors. And then there's straight a label, which is called a tag, and that's typically used to record milestones in a repository. So something like a release, for instance, so version 1, version 2, those type of tags. They could also be milestones within the project when you transfer to QA, for instance. So examples of those, these are branches here. this represents the SHA, so that long number that represents it, that points to a node, I should say. This is very strange to do without any feedback, Max. It's the first time I've done it this way. So if there's any questions, I guess I'd encourage people to ask them. Well, I guess I'll see them in the chat if they ask questions.
Well, I turned off the chat, but you can unmute yourself, guys.
Yeah, just I think we're a small enough group that if you just want to ask questions, just stop me and we can go over something in more detail. So anyway, with that mental model in mind, here's just some starting things. If you haven't used Git before, just to get going, the usual start of a project is the git init and git clone commands. So most of us will be working with an existing repository that either our company is working on or we're working on open source or whatever. And so we'll probably start with this git clone command. You can start completely from fresh on your own machine with git init, and it just initializes the current directory with some tracking files and whatever Git needs to keep its plumbing going. Git clone is going to copy from a remote repository into your own local repository. The repositories aren't my repository versus the remote repository, not particularly different from each other. They're really storing the identical information. So you have a full copy of the source on each of the clones that you make. So the commands that you use these are some of the common commands that you'll use to interact with Git. Just to retrieve information, you have a git pull, and then to copy information back to the remote, we have a git push. To control the config, there's an entry point called git config. And what this is running, these are running various scripts that are attached to the git command. Here's some examples. If you want to, when you're checking your code, as you saw in my examples, my name shows up and my email shows up, and that's because I've recorded it with this command first. So you edit your local config with your identifying information, and you can tell it other useful things like what editor you want to use. You can also just dump the contents of your current config and various commands under config anyway. I've left a link to this site here. That's the site that I'll be doing a bit of the demos inside this site here. I'm just gonna reset my environment now. We'll come back to this. Okay, so one thing that's a little different with Git, if you're coming from other systems, is these 4 stages that files go through. So the meaning of each of these is untracked is pretty obvious. It's not part of the Git repository yet, but it sees it in the folder that you've either initialized or cloned a repository to. Then there's modified, which means it's a file that Git is aware of that is in the project, and you've made some changes to, but you haven't yet done anything with it. So you've just edited the file without doing anything else, and Git detects that. Then this is the unusual state, this stage state, which is because the unit, again, of entry into each of those nodes of the thing is the unit is a commit. Preparing the commit, sometimes you want to do some staging on it. A lot of times you'll go right away from stage to committed, but the stage allows you to, yep.
Sorry, I got a quick question. The git commit -a. Is that amend existing commit?
No, this is add. This
Okay,
is
so it
means
does it add
it's
at the
doing
same
two
time?
actions in once. It's
Got
actually
you.
doing the stage and the committed together.
Okay, makes
By
sense.
doing a commit dash A or this dash AM here.
Okay,
This I often use it this way. So
okay.
at the command line, I'll commit and add any modified files. It won't add untracked files though.
So
So
it's the same as dot. I'm assuming dash A. Get add that.
yeah, with the caveat that it will only add unmodified files. Sorry, modified files. It won't add unmodified ones that you've just added. Like if I just added a file to this directory here, and I do my status on there, it would show it as an untracked file. And if I did a git commit with dash A dash M, or just dash A for that matter, it's going to ignore the file I just added. Whereas this command, this add, will explicitly add anything in that subdirectory, including untracked files. So that's the difference between the two.
Oh, okay.
The behavior, the semantic is similar. It's just the actual details are a little bit different there.
So the
You can also,
untracked
yeah,
files is that the git ignore?
no. So if it's truly a file that you don't care about or that you'd rather not have checked in, like a binary or something like that, then here, let me just create a file. I guess I don't have to spell some junk, right? I have to just think. So you can see my prompt change too. I'm using, I think it's on my Posh with Posh Git. On the Mac, I use my ZH Z shell. So if I look at the status now, Max, you can see that there's a. I must have had a test. I must have used this name before. Here, let me copy that to something else. Oh, it's because I have other. Hopefully that hasn't been used anywhere. Yeah, so now I'm showing unmodified. So if I look at the status now, you see I've got a modified file because this file must have existed previous in the I just got unlucky there. This file doesn't exist at all. So you can see it's in the category untracked files. And in order to add it to the repository, I would have to explicitly add either the file path itself or the directory that it's in. So git add dot, for instance, would add this file. So if I did a git commit though, only this file would get added. Does that make sense, huh?
It does. So untracked is the first time it hasn't been.
Yeah, if I do this, so git add, just the root of the directory. You can see I have, whoops. You can see I have both files added now. If I had done a commit, then done it through the commit, then only this modified file. So it's detected that this is a new file here. So I can show that. So if I remove that file there, and I do a git. So with that A command, so if I look at the status, you see that file is still there. It's still sitting in the untracked files, even though I did the -A. That makes sense?
Yes, it does.
So what it did do, is it created a log entry here for that, just because I added and deleted a file. The net result is nothing because that file didn't actually exist, but it existed sometime in the past in my history, that's all. Get rid of that. So that was git add. Thanks, Max. You can also stage just the single file if you just want to. You can. This can be a full file path here, of course, or stage everything that's in the directory down, as we just saw. So the main thing we want to we interact with in Git is the branches, of course. There's a bunch of commands around creating branches, but the main ones are here. This one will just create a branch, and then I'll illustrate that here. So if I create a branch, here, you can see it's just added a tag to that directory. This is, this isn't really Git here, but this is illustrating what Git would do. And if I commit now on that, you can see that, because I hadn't switched to the new branch yet, that command, that git branch new, or git branch, the branch name, all it does is create a new pointer at the current node. It doesn't change which branch is active, so which one I'm actively committing to. So in my command shell, I can see that I'm on this branch here, and that there's a bunch of commands. There's a bunch of branches in my local, and similarly, there's a bunch of branches in my remote. They don't have to be the same. Some of these I was just fooling around locally and don't exist on the server copy of it. That's the difference between this -r with and without the -r, is just get the branches either local or remote. And that's a common mistake actually that I make when I'm checking in code, is I'll create a branch and then forget to switch to it, and then go off, modify some code, and have forgotten that I didn't switch branches, and then commit to the main branch, which often in commercial, in production apps, is locked. They don't want people committing directly to the main. So it's one of the things that we'll get to in a bit, just how to fix that now, because I've committed to the wrong branch, but I want to move it to another branch. I still want to preserve the changes I made. So often what I'll do instead is I'll use this command, because it does two things. It switches which branch is active, and it creates the branch at the same time. So if I can show that here, if I do sorry, -b. So -b is create the branch. That's modifying that. So now you can see that, I don't know if that's big enough. Is that big enough to see on your screen, Max? Just the star there?
It's I can see
small.
it. It's a little bit bigger. Yeah, that's nice.
Okay. This is, I might have to zoom out when I do some other stuff, because it takes up a bit of a screen. But you can see there's a star there. So if I do a commit now, the difference in behavior is that main stays pointing at C2 and new is now pointing at C3. So the difference from what I did before when I created the branch here, actually I can change the active one here. No, you can do that. I never used the mouse in here. So the difference in behavior before is here I just created the branch and then I did a commit, but I was still in the main. And then with using this command here, because it switches the active branch, it's a little safer. So I tend to use that one for creating new branches. You can also so as you saw, as I clicked on here, you see the command that it's running is actually just check out the branch. So that's how you alternate. You switch between the branches. Something that comes up a fair bit when you're working with a lot of people is you want to see the commits that you made over the last week or two. So there's some commands that you can sort the list by their committer date. You can add author here as well. You can add the author name, and then that way you're just seeing what you've committed yourself. So this is exactly the mistake that we made before, is that we created a new branch, but it doesn't switch to the active one. So what can we do to correct that? I've gone a little further, so I'm going to undo some of it. This allows me to undo. That's not a Git thing. I'm going to undo some of these commands here. So this is the state where we made our mistake, where we've committed to the wrong branch here. And so if I just wanted to get rid of those changes altogether, I could reset the current branch. So there's two main commands to undo changes. One's called reset and one's called revert. They're quite different from each other, though. The reset is just really a manipulation of the pointer. It's moving where this main branch points to. And then it orphans the node that it used to point to there. So that's what this command would do, is it would force our pointer to move. So that's that built-in one we talked about at the beginning of the four types. That built-in one is going to push the head, so the active node, the one that's at the that we're committing to, it's going to move it back to, is what this command means here. So if I did that, I'm only going to go move back one. I didn't do two commits, I only did one. So I'm not going to do it hard either. Just do reset. It defaults to one. I didn't have to specify that. But so now you can see that, I don't know if that's obvious, Max, but this is grayed out now. It's still there though, which is, it means it's still in the repository. And that's one of the reasons it's, I guess I haven't lost very much stuff in Git, is even when you remove the pointer to it and effectively deleted this one from active service, you still have it in there in the repository. It's just an orphan. And one of the ways you can get at those is there's a regular way of looking at the log of what the history is, which I was showing him in here, where you do, I have an alias, I'll describe that later, but this is showing kind of the regular history of it. But there's also another command called, so that's git log is the base one. There's also another one called git ref log, and that shows everything that's going on in the repository, including orphans. So that's a way of recovering. You can actually we could go back and recover this node that we just lost there.
Actually, I do use git reset head and then go back to however commits. For the clients that prefer to have a single commit and a PR, right? So when you do a commit and you do another commit, and do a PR, and then in some clients, they prefer to have, when you do have a PR, like I won't want to see a one commit kind of thing. So what I do is I do git reset, go like if I have five commits back, and then commit again kind of thing. So on the PR, it shows up as one commit.
I'm not sure I understand what you're describing there. So there is a squash command when you do a commit, which would take, like if I committed multiple times here, it would take all those and compress them into a single commit.
No, but that's squash when you merge, right?
No, a merge is different.
Okay. So if I have, let's say you have a commit to new branch 1, 2, 3, right? and
Okay.
you want to all of those 3 commits to actually be one.
Well, so I'm doing what you just described there.
Sure.
So if you do this git reset, are you sure that you can reset?
I'm git reset had like a tilde 2,
So
right?
you do head. So
Tilde
this is
2.
what you just described, right?
Yes. Well, it's like
Or
2, right?
two, I
Not
guess.
3, but
Yeah,
yeah.
two. Yeah. So we go back to C1. So then
Yes.
the
And then
repository will look
I
like
push it
this.
again, right? As a 1 commit.
And then, oh, I see what you're saying. So when you reset back here, you have the modified files still.
Exactly.
So you do a bunch of commit. Wow, okay, that's kind of living on the
Again,
edge there,
it's
Max.
not pretty, but if you have a better option, that's not right.
Yeah, I would suggest a different option, but I mean, there are commands to squash commits together. You can actually put commits together, and that's a safer way of doing what you're doing. What you're doing is living a little bit on the edge, because when you do the uncommit, when you do this reset, it's meant for recovering from errors and that. But it's a clever way you're using it, is that you keep the history all the way through. So let me repeat what I understood you're doing now. So you make a change, then you commit it, and you make another change, you commit it, you make another change, you commit it, and you're all working locally. You haven't pushed yet, right?
I did.
Yeah. Then you do a reset. So I say, I want to see 1 commit for that, all those changes I just made. So you reset back to the node that you started from.
Yeah.
You have to be
And
careful to make sure you get that node. That's one of the
Yes.
tricks here, is that you might accidentally go to this node, right? Especially if you're doing relative
Yeah.
addresses here.
It's tricky, right?
Yeah, you can easily make a mistake there, especially with relative, even without relative. But if you can use the hash here as well, the SHA, instead to do this reset. Like you can, this is just a pointer to a node, right? Just head to. So you could actually like.
So instead of reset to head, you can just actually put the SHA in there.
I can actually just do that. You see.
Okay.
You can put the SHA in. That's a little bit safer maybe than using relative, but not as convenient, obviously. Because you're unlikely to get 2 SHAs. Even if you only use 5 or 6 characters, you're unlikely to hit the wrong SHA by doing it that way, right? But I would use the full SHA if I was doing it, because again, the risk is you go back way back in project history to some other SHA. But the preferred way of doing that, like you can do that if you're using, for instance, Visual Studio, it offers an option that on check-in, I think GitHub does too, pretty sure. It offers an option that it'll take your commits. So let me undo what I was doing there. If we go back to this state, yeah, so we're back at this state now. It'll take these 2 commits and squash them as it checks in your PR. So when you create your.
Sure, but that's upon the merge, it's gonna merge them into 1.
Yeah,
right?
yeah.
That's okay, but again, that's it. Again, the client
That's a
wants it
safer
to
way,
work.
but you can also run that command locally. You can merge them locally. I don't use the command, so I don't know it off the top of my head, but there is a squash, I think it's called, that merges the.
Squash or rebase to the master, like to the main.
No, rebase is a different activity.
Okay, I'm sorry. Just keep going, but put you down.
Yeah, yeah. I'm going to go over rebase and merge the difference between them. The squash is a bit of an advanced theme, so I didn't prep anything for that. But here. So I'm gonna go back to, I guess, the path I was on before. But so there's 2 ways. What Max just described there, which would be confusing if you're new to Git, is there's 2 ways that you can join up to another branch. So when I'm committing, so I'm gonna create a scenario here where I can I can actually do something. So let me, I'm going to go back to this node, and then I'm going to create a new branch here. And I'm going to commit some changes to it. So what you were describing, Max, is that what I can do now to join up with main is I can switch over to main now and merge another branch into main. So I can, that's one way of doing it. And this is the graph it creates for that scenario. So what it's doing is it's taking, again, you have to think of Git as snapshots. So what it's doing is it's creating a new commit, which is the difference between this state of the project and this state of the project, and creating a new commit for that. So it does a few steps for you, which is it's comparing these two, creating a diffgram for it, then creating a commit that represents that delta that you just created. And that creates the most complex history. And a lot of companies don't like that. So they prefer to use the rebase command, which is a bit different. So what has going on with the merge is it's comparing this state and this state, and it's creating a commit that resolves the differences between those two states. So if I make a change to the same file, for instance, I could potentially get a merge conflict here where two people work, because more realistically, this would be developer one, this is developer two, and we each make changes, and then when we go to merge together, something goes wrong because we've modified the same file, and it can't, for some reason, resolve those on its own automatically. So you'd create merge conflicts, and then you'd have to resolve those merge conflicts. You do get the same problem with rebase, but the difference is the way the history looks. So if I undid that now, so this is what the history looks like, and you can imagine if there's multiple developers, you get a fairly complex branching structure out of this. You get quite a difficult to interpret sometimes with the branches all mean and where a commit was done. The advantage of doing merge rather than rebase is that you have the full history. So you do know that the time that this was done and what node it was based on, what the change was only in that commit and the change in this commit and what time it was done, as opposed to when these were done. Because you're basing off the same project state here, this C1. You could potentially have done something that introduced a bug by and you would have a hard time seeing it with rebase because the bug is introduced because these need to be committed in a certain order, which merge takes care of because you have to actually merge these ones here. But let me show what rebase looks like just to contrast them. I can get back to where it remembers every little thing you do. Nice. Okay, so the difference between what we just did and a rebase is that instead of trying to merge these two states into one, what it's doing is it's going to rewrite the history. So for instance, if I wanted to, typically what you do is the new branch, you'd rebase on top of main. And what that means is it would take this commit and it would apply it to this project state. And this one, it would apply to the result of those two. So you end up with a very linear, so if I do that, oh, I'm on the wrong one. So what it's going to do is it's going to apply those. It makes copies, actually. You can see it leaves behind in the repository these orphan now nodes, and it creates new ones because the difference between C1 and C5 is not the same as the difference between C4 and C5. So it actually has to rebuild the difference there. So the difference between merge and rebase is one is you're always preserving your initial project states that you created, and then creating a new commit, which is the difference between the head of the current branch that you're merging and the branch that you're merging into. Whereas rebase actually rewrites the commit. So it's rewriting the history of the project. So we're always saying you might potentially introduce a subtle bug, is if a file got modified in this branch, which in this case you were building successfully here, and you know all the changes that went into this. Whereas here you might have introduced in an ancestor now that there was a change, say, done in C3 that also affects these, and this might not work anymore because of some change that was introduced. So you could have changed an API here that you would not have seen in this branch, and you would see it when you do the merge. You would see this. Here you would, because it's in a file that you maybe haven't addressed here, you might not get a merge conflict yet, and it'll just rebase and your code will stop working. So does that make sense, Max? I felt like I explained that in a long meandering way, but does the difference between merge and rebase make sense to you now?
Honestly, no.
Still
I
no?
still don't see it.
Okay.
I don't know if what is everybody else being? By the way, you can unmute yourself.
Yeah, we're small enough.
So far, my understanding is merge. You just keep all the history and keeps everything, and like pretty much word for word what you said. Rebase will rewrite the commits, as far as I'm understanding so far.
Yeah, like Max, the difference here, you can see you see the old commits are still there.
Yes, that's the rebase, right?
Yeah, from the initial creation of that branch, right? Those are the actual commits I would make. Whereas these are not the same nodes. It's creating new diffgrams basically, based on the state. So it creates a brand new commit here. It copies everything from the other commit, like your commit message and that kind of stuff. But the difference between these two nodes and these two nodes is going to be different, right?
Whereas those arrows going the wrong way, shouldn't the arrows go the other way?
It points to ancestors. So C6 points to its ancestor. It's not descendants, it's ancestors.
Okay. Yeah, usually
kind of
I'm used to the arrows going the other way, where it's not pointing to the very first thing I ever created. You're pointing to the last thing. I don't know.
Yeah. But it makes sense with Git because it is always pointing at the previous, like each of these nodes points at its ancestor. So the difference, Max, is that if you remember what the other image looked like, I had a commit here, a single commit, which pointed back at these two commits and also pointed at this commit. And that's the main difference in what the history looks like. Is this is a very linear history, and a lot of companies like that. And if we squashed the colors as well, then we would only have 3 commits in this history, right? So that would be equivalent of what you were describing, where you create a single commit for all your work on a given branch, even though you might have not initially created it that way. It would have a single node here by squashing these two. So the history becomes very clean, but it's also a little bit of a lie because this, again, was initially developed off this node here. So although it might just work, and most of the time it does just work off here, you can introduce a bug. For instance, like let's say I have a file here that I've modified that's an API that is called by the code in this branch here. when I introduce it here, I mean, there's obviously DevOps tools in place to catch that bad a mistake, but you can imagine when that's a little more subtle, just by changing a parameter type or something, not type, but the contents of a parameter. So the meaning, the semantics of a parameter, but bear with me. So we have here an API change. Here, the API change doesn't exist, so it works up to here, and it's pretty obvious when I merge from here to here what the problem was. Whereas if I apply it here, this is not going to compile at this point because it won't be calling the correct. The API has changed underneath it, even though that's not in my set of files. So it wouldn't catch it as a merge change. But I'm hoping that explains the difference too between the merge and the rebase.
I'm actually trying the website when you speak, just to try to
Your what?
muscle memory, right, kind of thing.
Oh, what you actually do?
Like the difference in behavior, right?
Yeah. So, when you finish committing a set of changes, the merge, the commit that gets created there is going to be a difference between the previous project state and the new project state. So you can see that when you, I don't think I have a picture. So let me modify something here. Here, focus doesn't matter. I'll just add something here. This command here can be used to see the difference between what the current project states the head is and what your unstage and uncommitted code is. So that's just doing a difference between them. Because I added this, I duplicated this line. So you can see in green, I've added this line here. And that's what it's actually going to be storing between those commits. So the other type of thing, so that change I made isn't a desirable change. I just want to revert it. So I could go back and edit the file and undo what I did, or I could just check out that single file. So the file is the miscellaneous file there. And now you see my environment's clean again. So I don't, that's the way, so if you made a bunch of changes that you really don't want, you want to remove them, that's one way you can do it. You have to be careful, obviously, because that actually will undo your work altogether. Like if I go back into the editor there, it's updated the thing. I have no chance of recovering that. So that is a way you could actually lose data if you're not careful. So as we were describing here, when I commit this, if the same file was modified in this history, in the purple history here, and also in the cyan history, then either through rebase or through merge, I would get what's called a merge conflict or a rebase conflict. And then one option would be to go and just find the mistake and fix it. Another is to use a merge tool where it's going to show you a difference between them. So if you're using Visual Studio or VS Code, they have difference tools in there. Or I use a specialized tool called Beyond Compare, which you can set up forget to use, so that when you do when you actually merge them in, you can call this command git merge tool, and it'll open up the tool of your choice. So you can configure that. I think by default it uses vim diff, but you can set that up to be anything you want. So if you use some other tool, like I don't know any others now, right now, Aliases or something is one. But anyway, and use that to resolve your differences instead. So Max, have you come back from your?
No, I'm good. Again, I understand the difference.
Okay.
Again, my original comment was about something else. It was more about, again, squashing the commits into one, then rebasing on something. But yeah, I understand.
Yeah, well, the two work together. Like if did you just search for the squash commits? What's
Yep,
the
I did.
command?
It's
Yeah.
squash merge, right? Squash.
Yeah. Oh, they're doing it your way. Yikes. Maybe that is the way people do it.
Yeah, no, I understand the risk, right?
It
If you
would
do
make
it the
me
wrong
nervous.
way, you're screwed, right? Well,
Yeah.
not really, right? And if you don't pay attention, then you're screwed. But that's
Yeah, I mean, like anything, I guess.
exactly.
There is a merge squash, I guess, but that does a merge, not a rebase. I don't know if rebase has the same.
No, but
same
see that
command.
one, what that one does, and I tried it just now, right? So like when you merge, instead of replaying commit 3 and 4 and into your feature branch, it merges them into one and then pushes them into like another commit.
Yeah. Okay. Well, I mean, yeah, as long as you're careful.
Uh,
Logically it
I
makes sense to me. Like
do
what
my
you're
best.
doing makes sense
Yeah.
to me. Yeah. What you miss out, of course, is like what would happen automatically for you if you used the PR tools way of doing that. It would automatically merge your commit statements as well. So it would join those up. Whereas if you're kind of doing that by hand when you do it the other way, when you just set this back to here, and then basically you've got all the unmodified files now, but every modification is there. And then you commit it as a single node. I don't know if people understand that, but what Max is describing is that you're in this, let's say we're in this current state here and we're on this branch. What he's describing is that, and let's say he made these two changes and he only wants to show to the system a single change. So what he's doing is he's using that reset to move his pointer up here. So he's taking this and he's pointing it. Let's do that. He's pointing it here, orphaning this node in his local repository. And then all the modifications here would be in his local directory. So, when you do this command where you do git status, it would show it clean at the point where we were pointing here because we had everything committed. But when you do this reset, it would actually, I guess I can do it. I'll go back one. And then you see it's popped that out into the modified file. So in this case, it's actually going to be showing as deleted, but because I deleted the file. So it's taking me back to that node and showing whatever change was made in this work would be showing up. So what Max is doing is he's actually reverting all the way back to C4. All these changes get dumped back into the environment as unmodified. So it takes all the things that you change and puts them in the environment as unmodified. And then he's creating a single commit for C5 and C6.
Yep.
The danger there is that you might accidentally go to C3. If you're using these relatives, if you use the SHA, it's less likely because they're so random looking. But to pick up the wrong one. But what it means is your workflow looks something like this. You do a git log with the last 5 commits or something. You'd grab this number of the one that you're interested in, right? You'd grab this and you'd reset to that point. You do a git reset on that SHA. I'm not going to do that. And then your environment would be like mine is right now, where I've gone back one. You'd have some stuff in the environment. So you'd have modified files, deleted files, whatever changes you made during that time. And then you commit everything at that point, right? You probably do this.
Yep.
Did I describe your workflow? Yeah.
Yes. Again,
So,
I do a staging separate from the message, but yeah.
Yeah. And the advantage, because these are so different from each other, and especially, and if you grab the whole one, there's no danger. So if you just copy paste, this is the safest, is you just copy that whole thing. And then when you do your reset, you know you're going to that one. What I'd worry about in my head doing the relative ones is that you type 3 instead of 2, you count it wrong, you know, and then now you're creating a mess in your source control. You would probably get an error in that case when you tried to commit, because you would have changed the history. So if you do the error I said, where let's say you wanted to go to C4, but you actually went to C3, but the state, this is committed in the repository. So when you went to commit that change you just made, it would have thrown you back and said, no, you can't commit because there's a difference between your history and the history in the system. So I guess it's fairly safe, Max. I mean, there would be an error there, and there would be some head scratching on your part trying to figure out what went wrong, but you could do it.
Mm-hmm.
Recovering would be a little bit of a bear from that situation locally, but you could do it. So, yeah, I kind of get why you do it that way. I've never worked that way myself, but I kind of get it. I like having the rich history. I'm the other way. I tend to merge rather than rebase.
No,
I don't care about the squashes because I like all the details. But
exactly, I don't care if I have 50 commits right in the again. That shows the history, the work that was done, right, and the reason why it was done.
It's the reality. It's what actually happened. So I kind of like it. Another trick you can do with rebase too is you can actually delete commits. Like if you let me just run this. Oh no, I didn't want to do that. Yeah, this site, it has you can specify a bunch of commands on in the URL in the query string. So I was able to create a query string that set up the environment I wanted. So that's similar to what we were playing with just before. So if I do something like, let me, so what I'm going to do is I'm going to take this, rebase it onto here, ignoring this one. So that'll effectively get deleted from the history. So I'm just going to take the C6 and stick it here. And I'm going to do it in a really hard way to read. So I'm, yeah, this is not enough of a clue for me to remember everything, but let me see if I can reconstruct it. So the onto command with rebase allows you to specify a node onto which you're rebasing. So the target of your rebase, right? So in my case, it's going to be new 1. That could have been back in history though, to delete, you know, if I had a linear history, that's what this example is built on. It's based on a linear history where I'm going back from my branch 3 and then I'm rebasing the last commit onto that, and effectively that removes the node in between. If you can, I think that's a better way to show it actually. Maybe I'll do that. Here, I'll just do that. So if I do, I'm gonna get rid of C3 here, if all goes well. So I'm on I want C4 to be rebased onto C2, orphaning C3. So what that means is I want to take my current state, so that's good enough for my current state, and I, sorry, want to, so head minus 1, 2, minus 2, and I'm gonna rebase my current state. I thought I did it. No. Oh, this is. Yeah. Yeah. Sorry, guys. I don't use this command very much. If let me go back to this state. So if I do what I was gonna do, I think I can do it this way. It gets confusing with the relative. So on to, I'm gonna take. No. Anyway, if I could figure out the command, it's already 7 o'clock. But if I could figure out the command, then you can actually remove the node in between by rebasing this on top of this. Basically, that's what that command's trying to do, and you're specifying it using the onto command. Oh, that's why I got it. I got the actual syntax wrong. So commit instead of yeah. Hey, there. So now C5 isn't in the history anymore. So what it's saying is onto new one, which is C4, take one back from head and start from and take new 2 and rebase that onto C4. So it's not the most obvious thing to do.
How do you cherry pick?
Yeah, so instead, like I can actually use this as a cherry pick here. So I could do cherry pick, as the name implies, means you can grab a single commit and drop it wherever you currently are. So I'm currently at C6 prime. So I'm going to do, I'll see, it should work with
Let's grab
C5
1, 2,
there.
4, right?
Yeah, I should be able to cherry pick C5.
No, I want more than one, right? I want 1, 2, 4.
Sure, you could, but they're already in the history, so I would have to create some new ones. Let me do the one first. Oops. Yeah. So that here I'll go back to new.
Oh, you picked it up from the orphan ones. Nice.
Yeah, that's what I'm saying with the rough log, where even if you've orphaned them, these show up in rough log, even though they're orphaned. And that's one way you can recover them, is you can use cherry pick to recover them. Mm-hmm. So it just added me to the end of the list here, and it does create a new commit. It leaves, again, it never pulls these out, it just creates a copy of them. But like if I went back to new 1 here and made a bunch of commits here. Right, so this is what you were describing. You want 8 and 9, let's say, added to here, right?
Sure.
Is that what you were? Yeah, that's what you were describing. So if I
You need to switch to 2, right?
Yeah, I got to check out to 2 first. Then use that same command, cherry pick. But now specify a list instead of like that. And I can reorder them here too. I can do C9, C8. So
Do that. Yeah. More fun.
So it's actually a way of reordering your commits as well. So now it's rewritten history pretty dramatically from what it is. Let's flip these 2 around and added them at the end, and I just ignored C7 and C10. Where I've mostly used it is where you're in a scenario where you've had someone branch off to do bug fixes, and then you're working on production, the next release. So it's in the model where the current activity is mainly focused on the release, but a hotfix has to go in. So you create a hotfix branch, you make the changes you need to, but then it turns out that one of the changes that's over here has something to do with the bug that you fixed. And so you want to cherry pick that fix over into the hotfix. Or similarly, you want to go the other way, where you make some changes, some of which aren't relevant anymore because the code base has changed, but there might be one commit in here that is important to get into the main code base, and you don't want to redo that work. So then you'll cherry pick that one node into the main line instead. Those are the ways I've seen it mostly used. I've also used it to recover an orphan node. Just grab one the way we did there.
Yeah.
I've used it in that case too, where I accidentally, moved back too far in history or something, and didn't, for some reason, I don't remember the situation, but there was some reason I didn't want to just recover the node normally. Okay. I think that was pretty much everything I had anyway for tonight. There's some stuff on customizing. Like if you look at that log I was producing.
The log?
It's called. I copied it from someone. They named it that. But yeah, my history's pretty linear. I'm checking at the main, I think. I did a merge there, but this pretty print, which is much more compact than the one you get by default, which looks like this. That's not very compact, and it doesn't show the pretty stuff. But to get it to do that, you have to do something like this, right? You have to put in this pretty format. You have to tell it to use the graph. And that's a lot to type. So what you can do instead is just create an alias for that. So you basically copy that command as you would run it without the git in front, obviously.
Okay.
And then you can store it in your aliases. So in mine, I have if I just if I just pull out the aliases. So aliases look like that in the config. This is just a text file, by the way. You can go and find where it stores this in the .git directory and just go find these things and edit them there if you want to, which sometimes is easier than running the command. This command will go and modify the file for you. And the nice thing about it is, of course, it's going to do everything correctly or give you an error if you're not doing it correctly. But you can see I have a bunch set there. So like commit and checkout and status. I get tired of typing the full thing, so I just have abbreviations for them. And then there's a bunch of ones I use for the logs. Right, that's pretty much everything. If
that's neat.
anyone else has some questions, I'm happy to answer too. But I hope you got something out of it.
I did.
I had a quick question. For a personal project, I accidentally published my security keys for like a API access. I took the whole project. It was early stages, so I took the project off. But
Yeah.
and republished without the key, but is there a way to fix that without having to redo the repo?
Well, yeah, unfortunately Git remembers, but what I was describing here with these orphaned ones, that's a temporary state. There's a command that every once in a while when you do a pull, or I forget what triggers it's probably, I think it's on pull. It might be on push and fetch as well. It does a compact on your repository and it'll remove orphans at that point. So it does recover eventually if you do orphan those nodes. If the commits are in a separate thing altogether, then you can go back and do it. And you can, depending on which state your repo is in, you can selectively remove those nodes out of the repo and orphan them, and then it'll get compressed on the server. So you can, but someone's clever enough during that state where it's still in the repo, but not, it's still orphaned, but still in the repo. They could actually.
So if it was orphaned, I can eventually, when you say the compress stage, it gets rid of the orphans.
Yeah, it removes them. It does compress on its own. Like it has I forget what the triggers are for it, but I think it's size triggered. So once it gets, enough junk that it knows it can collect, it does kind of a garbage collection model on it, and it removes them. The hosting, where's it hosted? Is it GitHub or is it?
It's GitHub.
Yeah, it might be that they run that clean all the time. They might run it every time there. So if you orphan it, then, but you have to force, unfortunately, to orphan something, and then something way back in history, you have to do a force on it. Which, if it's your own private project, you can do that. You would have to actually force update so when you do a force push, to get rid of the node on the server. Okay. Do you know what I mean by that?
Yeah, I know what you mean by that.
Yeah, it should give you enough to search on anyway, because if one of the commands is force, and which you should never use when you're collaborating with other people, really, except under dire circumstances. Like that would be one, I would guess. If you had just committed it, you might do a force to get rid of it.
Cool, thank you.
Yeah, that's a drag.
Yeah.
You couldn't redo your keys.
I didn't see an easy way. Plus, it was very early in the project, so it was like 10 button clicks.
Okay.
GitHub has this filter repo. I'm assuming you've tried that one, right?
I don't know that one.
You can search git filter -repo and GitHub. It gives you a detailed article on how to clean up sensitive data from your history.
I vaguely know that one. Yes, I was reading on it, but I was reading it after I had already done the whole redo everything.
Yeah, because GitHub now has this new for the public repos, right? They can detect the secrets and whatnot, and it can prevent you from doing all this stuff, like getting yourself in this kind of trouble, right?
So
and
do you
it's
have to
free
turn
for
on
public
rules
repos.
then? You have to turn on a rule for it, or?
I believe
last
so.
I checked, they did it automatically because I got the email, and that's how I knew that I had accidentally published.
Okay.
I mean, the other option is if you clean your local repo of the offending node, and then you do the force compress locally, you can restart the project. You can just blow away the repo altogether and recreate it from yours, right? So that's another option.
True. I do enjoy that there's like 10, more than one option for almost anything to do in Git.
There's like 20 usually. Yeah, there's so many different ways of accomplishing the same thing. Like you could theoretically do rebase using cherry pick. It's crazy.
I have to hop off, but appreciate your time.
Yeah, no problem. Thanks for listening.
Any other questions? I think we're good. Thank you. Thank you, Andre.
All right.
Thank you
Yeah,
for the session.
my pleasure.
Thank you.
Thank you. Thank you,
Okay.
everybody, for attending. Thank you all. Bye.
Thanks. Good night.
Bye. Take care.
Night, Max.
Thank you.
Long.